Okay. All right. So we did a study of the profit maximizing firm. We formulated the profit maximization problem. There were two approaches. One is the two-step process. First, you construct the cost function from the production function. And as a second stage, you do profit maximization with respect to just output. You could also take the direct approach and you can formulate the problem as one of choosing an input vector. So you directly jump to profit maximization. Now, we saw the implications of the assumption that firms are profit maximizers. And the qualitative implication of that is that each of the input demand functions are downward sloping and the supply function is positively sloped. So if we have a fixed number of firms in a market, a given number of firms, say 10 or 15, then the market supply function is just the aggregate of the individual firms' supply functions, right? You add them up horizontally, and that gives you market supply. And then you look at the intersection with the demand curve, which is derived from consumers' utility functions, and you get the market equilibrium. And you can do comparative statics and everything. Now, there's one additional step to discuss. A market may have free entry and exit possibilities. So if firms are not making profits, then some of the existing firms may quit that business. We see examples all around us. You take the telecom industry or the airline industry. Over the last several years, there have been several exits, some of them big firms like Jet Airways, for example. On the other hand, if existing firms in the market are making a lot of money, then new firms may be tempted to enter the market and set up business there. So the number of firms may be variable. Now, the time horizon over which we are doing our analysis matters over there. If you're talking of the airline industry in India over the next month, then we can safely assume that the number of players will remain the same, right? 1 month is not long enough for a new entrant to come into the picture. But if you're talking of the market over the next 5 years, let's say, then we have to take into account the possibility that there may be either exits or entry, okay? So for want of a better term, let's call this the very long run, right? It's a time horizon over which even the number of firms in the market is variable and endogenous, that new firms may come in or some firms may quit. So then an additional variable which we have to solve within the model is the number of firms, okay? So what will be the market equilibrium in the very long run? So to explain that, let me use diagrams.
So this part is in continuation of module 3 only, right?
That's right.
Okay, sir.
Okay. So let me draw the cost curves of a typical firm. Oh, I don't know what's happening here. Just give me a moment, guys. I need to close this and try this again. Okay, so this is the cost curve. I'm going to draw the cost curve of a typical firm in the market. So the firm's quantity is Q, and prices and costs are on the vertical axis. Now, let's say that the firm's, well, first, let's draw the average cost curve of the firm, okay? One shape which is typically, often assumed is that the average cost curve is U-shaped. Maybe initially there are economies of scale, but eventually diseconomies or decreasing returns set in, and that pushes the cost curve, average cost, up. So let's consider such a shape. I'll also have to draw the marginal cost curve, okay? And marginal cost may also initially be falling, but then rising after a point. The critical thing to remember is that there's a particular property or relationship between marginal and average cost, which I'll show in the picture. And this property is that the marginal cost curve has to intersect the average cost curve at its lowest point. Look at the point where average cost is minimum, where its first derivative is 0. At that point, marginal and average cost have to be the same. How do we show that? Well, you can just show it mathematically. For example, what is average cost? Well, it's a function of quantity, right? It's the total cost function, CQ, divided by Q. So if I take its derivative, I get 1 over Q squared, Q times C prime Q minus CQ. CQ times derivative of the denominator, which is 1. All right. That gives me, if I take, if I divide what's inside by Q, one of the Q's, so I get 1 over Q times C prime Q minus CQ divided by Q. Okay. So this is basically the derivative of the average cost function is essentially marginal cost minus average cost, right? And so that means that whenever average cost is downward sloping, so this derivative is negative, if this is downward sloping, that means that this term has to be negative, so marginal cost is less than average cost. And if it's positive, then that means marginal cost has to be greater than average cost. Yes? The idea is very simple. If you want to kind of wrap your head around it, it's that, suppose, let's consider this class. Everyone in this class, let's think of our average income. Yes. And suppose we add a new member to the class. Stretching credulity, let's assume it's Jeff Bezos, the richest, the second richest man in the world right now. Now, in that case, what will happen to the average income of the group? It'll go up, right? And what is the relationship between the marginal income, the income of the last member of the group, and that of the others? Well, marginal income of the last guy, Jeff Bezos, is higher than the average income of the rest of us. So when you add somebody whose marginal value is above the existing average, it pulls up the average. And if you add somebody who's the opposite of Jeff Bezos, somebody who is unemployed and has no income, so then the marginal income of that latest member is above our average, and that'll pull down the average, right? So that's the way to kind of understand this. So that's why when we draw the average cost and the marginal cost curves, it has to satisfy this property that the marginal cost, in the stretch where average cost is declining, the marginal cost curve has to be below. In the stretch where average cost is rising, marginal cost has to be above. So the intersection has to be at the lowest point. Okay, now we saw the profit maximizing principle. Okay, so the next thing we'll do is we'll identify in this picture the supply curve of this single firm. Okay, and then we'll go to the market. So in this picture, what is the supply curve of the firm? We saw that the profit maximizing principle is the firm chooses a quantity where price and marginal costs are equal. Okay, at least that's the first order necessary condition. But there are caveats. Okay, so we have to keep those caveats in mind. So in this picture, let's consider first a price like P1. So when the price is P1, applying the rule price equals marginal cost gives us this Q1 as the potentially optimum quantity. Now, the question to ask here is that, one option for the firm is to shut down altogether, to produce nothing. So we have to compare this interior optimum, right, or supposed optimum, with the option of going to the corner and producing nothing at all. Now, producing nothing at all gives zero profits, okay? And at this Q1, is the firm making profits? Well, yes. How do we know that?
The average cost of producing that quantity is less than the price of producing that quantity.
So price is above average cost. Right? That immediately tells us that on each unit, there's a profit which is given by this gap. So the total profit actually is the rectangle. The area of this rectangle. Okay, now, however, let's consider a price like P2. P2 intersection with the marginal cost curve happens at that point, and so we have a candidate for optimal quantity P2. However, this is a false candidate, okay? Because if the firm produces Q2, then its average cost of production will be higher than the price that it can get for each unit. So the firm will be actually making losses, and it can avoid those losses by shutting down altogether. So, guys, please unmute yourselves. Somebody has the microphone on. Now, what is a critical value? A critical value is a price that just grazes the average cost curve at its minimum point. Okay, so let's call that P bar. At this point, the firm, applying the principle price equals marginal cost gives us Q bar as the quantity that ought to be produced. And the firm is making zero profits. If it shuts down altogether, then it'll also make zero profits. So it's indifferent between shutting down and producing this amount, Q bar. Okay. So to tie it all up, the supply curve of the firm is not the entire marginal cost curve, right? It's the part of the marginal cost curve which lies above average cost. That's the principle. So this part of the marginal cost is very much the supply curve of the firm. But once we hit this critical value P bar, supply, then below P bar, the supply curve actually grazes the axis. Supply is zero at all prices below this. Okay, so that's the way to identify the supply curve. Yes, Stuti.
Sir, isn't shutting down a short-run thing, and we should compare it with the average variable cost rather than the average cost?
I mean, you can apply the same principle in the short run as well as in the long run. Okay, so what I'm saying here is, so let's say that, average cost incorporates every kind of cost, including fixed costs. Okay, so in the long run, let's say that, in the long run, when all factors are variable, this analysis still applies. Okay, and if we are looking at the short run, there's a similar analysis. Okay, if there's a fixed cost which is unavoidable in the short run, then you keep the fixed cost out of the picture, and you draw the short run average cost and short run marginal cost curves, and this is the so-called break-even point. And if the market price is below that break-even point, then even in the short run, it's optimal for the firm to stay shut, keep paying the fixed costs till they become avoidable, and that would be the optimum decision. So nothing in this analysis has anything special about whether it's short run or long run, right? The same principle applies.
So, sir, when we are saying shutting down in the long run, we actually mean that the company or the business is just stopping everything for like.
Yes. So in the long run, it just means that you just fold up, you sell off everything and just wash your hands off. In the short run, there are some fixed costs you have to pay for a while. For example, rent on the office that you've rented. And if your cost curve based analysis shows that you should, your optimum quantity is zero, then you basically, pay the rent, but keep your store shut and stop paying rent when the contract expires. That's all it means.
Okay, thank you, sir.
Yeah. Aishwarya.
Sir, in our undergraduate courses, we were told that the upward sloping part of the marginal cost curve is the supply curve. So how do we reconcile the difference?
It's not the upward sloping part. I mean, you can, well, let me, one thing is for sure, right? That the part of the marginal cost curve which lies below the average cost curve is irrelevant as far as the supply curve is concerned, right? Anytime the price hits that part of the marginal cost curve, there will be losses rather than profits, and so the optimum quantity would be zero. You can see that from the picture, right?
Yes, sir. Yes.
Okay. Now let's look at the so it absolutely has to be that part of the marginal cost curve which is above the average cost. That is for sure. Now, suppose let's say it's non-monotonic in this region, let's say. Yes? Let's say it goes like this. Now, let's think about it. I didn't do a good job of the picture. Let me redraw it a little bit. let's say there are segments like this. Okay. Now, let's take a price such as this price. Now, it intersects the marginal cost curve at two places. Okay.
Sir?
Wait a minute, let me finish what I'm explaining, right? Then you can ask your next question. This is Q1, this is Q2. Okay, so there are two candidates. Now, which one is the right profit maximizing quantity?
In my opinion, it should be Q1.
It should be Q1 because remember the second order condition. The second order condition says that at a profit maximizing point, marginal cost has to be increasing. Yeah. Right? So Q2 does not satisfy the second order condition. And, well, actually, there's a third point over here, which is Q2, Q3. So there are two local maxima. And there's a third point, which is actually a local minimum.
Minimum, yes.
So the actual supply will be Q1 or Q3. And the only way you can determine which is by computing the profits at these two and comparing them. Yes. So one thing is for sure that the rising parts of the marginal cost curve, the supply curve can only come from the rising parts of the marginal cost curve. This downward sloping portion will not be part of the supply curve. Yes.
So we can conclude that the supply will always be from the positive part, but not the entire positive part of the marginal.
That's right. So the supply curve will only come from that part of the marginal cost curve which lies above the average cost curve, right? That is necessary. That's not sufficient. That's necessary. Now, within that segment, it has to come from the positively sloped part. Again, that is necessary. That's not sufficient. So that's what we can say.
Got it, sir. Thank you.
Yeah.
Sir?
Yes. What was the question which I kind of postponed?
Sir, actually, can you just shift to the graph that you just draw just now? So in this case, when there's a kink in the marginal cost curve, the part where it is downward.
I've drawn it smooth.
Sorry. Not a kink, but it's a smooth curve. But yeah. It's at between between in that place, particular place Q2, it's downward sloping, right? For that region, won't the average cost curve also look in a different way, not always increasing monotonously?
Sure. Yeah. But let's just assume, yeah, it can go. But let's just assume that it still lies below.
Okay, sir. Thank you. That was my question.
Yeah. Any other? Rishi?
Sir, my question is, sir, why would a market like this ever exist if nobody is even going to earn in the long run as well? I mean, we can say that in short run, people may not earn with a possibility. Yeah, it's short run. But even if in long run, they are not earning, then why do they want to stay in this market?
They won't. They'll leave. So I'm coming to that.
Okay.
That is very much part of the analysis. As I said, whether firms want to stay or leave or new firms want to come in, that is exactly what we are looking at. Okay. So we are going to look at that. Okay, so let me go back to the original picture which I drew. All right, so for the individual firm, it's the red part that identifies the supply curve of the firm. Now, let me draw a parallel picture for the market. Let's assume for the sake of simplicity that all the firms in the market have this same cost function. That's not necessary for this analysis, but let's assume that, okay, the firms are homogeneous. So there's a demand curve. So the supply curve in the market will basically start at this break-even price, P bar. And at that price, whatever this one individual firm supplies, that times N, the number of firms, will be the market supply. And so the market supply curve will be the sum of individual supplies. And there will be some demand curve in the market. So this is the aggregate supply, this is aggregate demand. And that'll give us the equilibrium market price. Now, if we extend that equilibrium market price back to this diagram, then what do we find? We find that each firm is going to produce this, let's call this P superscript 1, Q superscript 1, or capital Q superscript 1. Okay, so each individual firm will be supplying Q1. But the most important thing is the firm is making profits. Okay, and remember, as I said earlier, at the very beginning, the cost curves are supposed to incorporate all kinds of costs, including opportunity costs. So if the owners of the firm have invested their own money in the business, the interest that they have foregone is very much counted as a part of the cost. If they're putting in their own time and labor, then the salaries they have foregone is also part of the cost calculations. These are comprehensive costs in the economic sense. And the profits we are talking about are also economic profits, profits over and above what the firm using its resources could have earned elsewhere. So there is positive economic profits, all right? So this will tempt new firms to enter. Firms elsewhere will find this market lucrative enough. So when the number of firms increases through entry, what happens to the market's supply curve? Initially, the supply curve was S1, right? This is for a fixed number of firms. As new firms come in, obviously, the supply curve shifts to the right. And as that happens, the market price falls to some lower value, P superscript 2. And as I have drawn it, each firm has to adjust by producing a little bit less, Q2, okay? And their profits are squeezed a little bit. They earn less because of the new entry. But in this picture, they're still making some profits. So that means still more entry is going to happen. So these supply curves keep shifting to the right. And when does this process end? When does entry come to a halt? That's when there is no temptation for outsiders to enter this market, which means when the price through entry has dropped to P bar. At P bar, there is zero profits, okay? So when zero economic profits, that means this market is not more attractive than the other typical investment avenue, other markets, nor is it less. It's just as attractive as any other market. And that's why entry stops. And if we started with a situation where there were, for some reason, too many firms, so the market price was, for some reason below, then that will lead to exit. And once again, in the very long run, through exit, the price will tend to rise to P bar. Okay, so let me call this the very long run, where N is endogenous, the number of firms in the market is endogenous, and the equilibrium condition, that is the number of firms that will finally exist in the market, that N star, let's call it, that is determined by the zero profit condition. The last entrant into the market must be making zero profits, okay? This zero profit condition pins down what in the very long run, what in which state the market will exist. And if you want to kind of draw the supply curve, although the supply curve for a fixed number of firms is positively sloped, in this case where I have assumed identical cost functions for all the firms, there the supply curve will basically be a flat line at P bar. What is P bar? P bar is the lowest value of the average cost curve. Okay. At that, there's a vertical or rather a horizontal supply curve. Okay. So the market price essentially will always settle to the lowest point of the average cost curve. So if you have a problem, for example, where the cost function of an individual firm is given to you, and you have to find, what is the market price in the very long run, and how many firms there will be in the very long run. What you have to find really is the lowest value of the average cost, and that's where the price will settle.
Sir, can you go over why the supply curve became flat again for the industry?
Because entry keeps happening till the price hits this level. Entry and exit keeps happening, right? So the price will always gravitate to this P bar. And at this P bar, so what happens, for example, if the demand curve, suppose we are initially in this situation and the demand curve, shifts to the right. Okay. Now, at this situation, there was a certain number of firms, okay? And suppose for a while, that doesn't change. So for the fixed number of firms, you have this positively sloped supply curve. So if the demand curve shifts to the right, the price for a while will go up. But when the price goes up, this will induce new firms to enter the market till the price goes back again to P bar, right? So that means supply will expand to this point. Okay, so that's why.
Yes, sir, got it.
Okay, Sameer.
So just one thing, in our undergraduate text, normally for the long run, and they often give a different AC and an MC. So does that normally happen, or is that just a illustrative thing?
What do you mean?
Or is this
different?
So in some of the undergrads books, at least what I had read, they had like to show the new price, right? The price at which it settles at. Some of them had a different, like a LAC or like the long run average cost curve.
Yeah.
Right. So is does that actually happen, or is that just an illustrative thing to show it? Like normally we have a short run average curve which is enveloped by a long run average curve, right? Like at a point where the MC is supposed to settle. Right. So is that what happens when there are shifts of the multiple firm entries?
See, typically in textbooks, when they talk about long run versus short run, they're talking about different time horizons for a single firm, right? In the short run, supposedly some factors can be changed, like typically labor, but some factors cannot be changed because the time is too short. For example, the number of, the capital stock. So if we are talking of an airline, for example, they can lay off some workers, or they can hire some workers on short notice, but to expand their fleet of planes will take a long time. So if you're talking for the next month, then expanding their fleet is out of the question, but changing their labor force is something that they can consider. It's doable. So that kind of time horizon can be referred to as a short-run decision-making for the firm. Okay, so for that thing, you have a short-run average cost, you have a short-run marginal cost. So I can prefix these things with short-run. Okay, now if you're talking of the next 2 years for the company, they can change all the factors. They can not only change their labor force, they can also buy new planes or sell off some of the existing ones. So you take that into account, and then you construct the cost functions, assuming that both labor and capital are variable. then you get, something looking like this with the prefix long run marginal cost, long run average cost, etc. Right? So one distinction between so-called short run and long run is that whether only a subset of the inputs are variable or all the inputs are variable. Okay, now there's another distinction which is at the market level, not at the firm level, which is, is the number of firms fixed in this market, or is that variable? Is entry and exit possible? So again, once again, if you're talking of the next 3 months, for example, in the airline industry, then it's probably safe to assume we won't see a new player emerging within these next 3 months. Okay, there may be talks of one, there may be sort of, as there has been Rakesh Jhunjhunwala, I think he's starting a new airline. There's always talk. But if you're talking for the next 3 months, probably it's safe to assume that the existing number of players, all your Indigos and Vistaras, they're the ones, it won't increase. But if you're talking for the next 3 years or 5 years, there's the possibility of the number of firms changing. So that's the second distinction. Now, undergraduate textbooks just make a huge fuss about short versus long versus whatever. I'm trying to give you the gist of it, right? So forget about definitions. We are trying to understand the logic and trying to relate it to the real world. Okay.
So my thing is that if like in a conventional case, or let's say labor and capital, in a short run, capital is fixed, right? So if we take a long run time horizon, then considering capital is a variable, then the average cost, like the curve would change, right? If we consider,
of course, the curve will change, yes.
Right. So that's why I was asking, right? So there is often a different curve. That's why we have.
Of course, the short run curve and the long run curve will be different, of course. But the fundamental principles that we're talking about does not change.
Okay. Yeah. Okay. I got it. Okay. So that was just confusing. Thank you.
Yeah. All right. So that's the principle. Now, sometimes this curve may not be vertical, horizontal, flat like this. There may be many reasons why, even in the long run, after allowing for entry and exit, you may have a positively sloped supply curve. One of the reasons could be that all the firms are heterogeneous. They don't have the same average cost curves, right? You may have one firm, you may have, you may have a most efficient firm which has the lowest average cost curve like this. Then you may have its closest rival, which is another firm which has a slightly higher average cost, and then there may be a third. So the first to enter this market will, of course, be firm one. If any firm enters and stays at all, it will be firm one because they have the best costs situation. But if the price is high enough, then the second firm will enter. If it's even higher, then the third firm will enter and will stay in the market, and so on, right? So if you have heterogeneous firms whose minimum average cost happens at different levels, then entry will stop when the last firm to enter is earning zero profits, right? The other firms, the ones who entered before, who have better costs, they don't have to earn zero profits. So zero profits is a marginal condition. It applies to the marginal entrant. And it's not hard to see that in a situation like this, when you have different cost curves for different firms, your supply, long-run supply curve, very long-run supply curve could very well be positively sloped. Yes, if you want more and more supply from the market, you need more number of firms to provide that supply. And that means the last firm to come in as a higher average cost curve, and their minimum point is higher. So that leads to a positively sloped supply curve after endogenous entry. Another reason could be that, as more firms enter, they're buying inputs from other competitive markets, and that may, if this market expands through general equilibrium effects, the inputs they use, like labor and capital, they may become more expensive, so et cetera, et cetera. Anyway, the easiest way to think about a positively sloped version is to think of heterogeneous firms and cost curves, right? Yes, Ria.
Sir, I had a confusion here. When more firms enter the market, or so the supply curve increases and the price for the entire industry goes down, right, in that graph. So, sir, isn't it that each firm will now earn less profits? Like profits go down for each firm. So why is it that entry and exit is only a marginal case? Shouldn't it be less profits for all firms in the industry?
Yeah, it may be less profits, but it doesn't have to be zero profits for everyone. If some of the firms have a cost advantage over the last entrant, and if the last entrant is making zero profits, then these better firms who have lower cost technologies, they cannot make zero profits. They'll make positive profits. So yes, if you're in a situation where only these two firms are there in the market, there'll be a certain market price and they'll make some profits. And if this third firm comes in, A, the two existing firms will earn lower profits. That is true. B, if the third entry is the last firm to come in and nobody enters after that, then this last entrant, the third firm, will make zero profits, right? So even though the profit of the first two firms goes down, they don't go down to zero.
Okay, sir. Got it. Yes.
Yeah. Okay. So this is sometimes called Ricardian rent, firms or businesses which have an advantage over the others, they can make some positive profits because of things like this. They have a cost advantage. So for example, in the crude oil market, the way it functions is that, the various oil fields all over the world have very different costs, right? So many of the Middle Eastern countries have the sort of cheapest crude. Yes, it's close to the ground, it's easy to pump out, their cost of production is among the lowest. And then you go to, let's say, some sources in North America, the tar sands, the fracking industry, where they extract oil from some coastal, I don't know exactly, rock formation or something. And that has much higher cost of production, okay? So when there's a lot of demand in the market, then these higher cost sources, even they find it profitable and they open up their wells. And the market equilibrates when some high cost oil well kicks into production, but just about, yes. But even at that point, the Saudi Arabian and Kuwaiti oil fields, because of the low cost of production, they're making profits. Yes, but when, due to a demand shock or whatever, the price starts going down, the first ones to shut down are those high cost sources like the fracking oil fields from Canada or the US or something. But the Kuwaiti oil fields still stay in operation because they're lower cost. Their profits are squeezed, but they can operate even under lower prices. Yes. So the marginal oil field is where all the action is. As the price moves around due to demand shocks, the ones which shut down are the high cost ones. The ones which shut down or open up, right? Okay. Any questions? All right, there are problem set questions, I think, where you will kind of, this gets drilled in more. You have to work through precise mathematical problems so that you get a full grasp of this. So let me move on to the next topic. And I haven't uploaded this yet, but I'll do it right after class. This is the section on monopoly. Okay. So we discussed earlier, one central result is, of course, the famous invisible hand of the first welfare theorem, which says that markets generally lead to Pareto efficient allocations. And then we went through a whole list of assumptions that that conclusion requires. Absence of externalities, no public goods, no asymmetric information, etc. And one of the assumptions that we identified as critical is the assumption of perfect competition, the crux of which is price-taking behavior. Consumers and firms take the market prices given and choose their quantities optimally. They don't assume that they have any influence on the market price. That assumption turns out to be absolutely critical. So, of course, there are markets where this condition is not met. And there's a whole range of markets where we may move away from perfect competition. But the extreme end, perfect competition is like one end of the spectrum. The extreme other end is monopoly. So we'll now swing to the other extreme, and we'll study monopolistic markets. Okay, and monopolies can arise for multiple reasons. In some situations, when intellectual property rights are involved, where the product has to be developed with substantial R&D expenditures, the way innovation is encouraged is by giving out patents and copyrights and stuff like that, right? So those are artificial monopolies. Those are monopolies created by law. For example, for patented drugs, medicines, that sort of monopoly is created. We also discuss natural monopolies, right? So utility industries, railways, they have very high overheads. And so the average cost is just declining over a substantial range of output. And that tends to, even without any kind of legal provision like patents and copyrights, it tends to leave only one firm in the market who has a huge cost advantage because they're producing in large volume. So whether it's a natural monopoly or an artificial monopoly, we need to understand what will happen unless the market this monopolistic market is regulated. They are often regulated. But to understand what regulation is required, we need to sort of study the market and develop some theory of it. So that's what we'll do. So we'll start with the usual simple analysis, and then I'll talk about other variants of it. So there's a monopolist market. Okay. The primary difference from perfect competition is that if one firm is serving the entire market, that firm realizes that it has substantial impact on market price. How much it decides to produce and sell will affect at what price it can sell, okay? Because they're the only ones who are supplying it. And in particular, if the seller wants to expand in volume, sell more, then they know they have to bring down the price. How much do they have to bring down the price? Suppose they have done their market research and they have estimated a demand curve. From that demand curve, they can know how much they have to reduce the price if they have to sell 10% more, okay? Or conversely, if they want to raise the price by 20%, they know they cannot sell how much they're currently selling. So they have to cut down on their sales because at a higher price, there won't be enough buyers as now. So again, if they have somehow estimated the demand curve from actual data and surveys, then from that they can read off, what kind of adjustment is necessary. Anyway, so a typical monopolist can, suppose the monopolist knows the demand function. Okay, so this is our inverse demand function, P of Q. The monopolist also has a cost function. Now, you can formulate the monopolist problem either as one of choosing quantity or one of choosing price. It doesn't matter, you get the same answer, right? But you have to do one or the other because there's really one degree of freedom. If the monopolist sets a sales target, Q, then at what price it can sell is determined by the demand curve. Conversely, if the monopolist has a price target in mind, I want to charge this price, then from the demand curve, it immediately tells the seller what quantity he should produce. He doesn't have the luxury of choosing P and Q as independent variables, right? The moment he chooses one, the other is fixed by the demand curve. So let's formulate the monopolist problem as one of choosing quantity, okay? So this is the profit function. P of Q times Q, that's the revenue minus the cost. Assuming an interior solution, if we apply the first order condition, right, derivative of the profit function equal to 0, we get this. By chain rule, the first term, when you are differentiating the revenue part of it, you'll get two terms, right? Derivative of Q is 1, so that gives you this, plus Q times derivative of the other part of the function, which is P prime. And that ought to equal C prime. So this is marginal cost, all right? And this is marginal revenue. These two terms together capture how much P times Q, the revenue term, is changing when you increase output a little bit. So this is what is called marginal revenue. Marginal revenue consists of two terms. The first term is the price itself, and the second, there is another thing, which is negative, okay? Let's forget about given goods. Given goods are very rare. Let's take normal good. So the second term then will be negative, okay? And that's very important, but I'm going to come to that. So the optimality principle for the monopolist is this: marginal revenue equals marginal cost. Now, let's rewrite this same condition in two equivalent ways, because they're going to give us some insights about this optimality principle. So that's on the next slide. One way to write the first order condition is like this. Okay, what have I done here? I've taken the price as a common term on the left-hand side. Okay, so the first term here, of course, is price itself. So if I take out P as a common factor, I'll get a 1 from here, and over here I'll get Q divided by price. Okay, Q divided by price. The subscript M denotes the optimum point for the monopolist. This is the optimum quantity, this is the optimum price. Okay, so this is just simple algebraic manipulation of the left-hand side. But now if you start looking at this second term, it looks very much like elasticity, except that things are flipped around, right? It's a reciprocal of elasticity, of price elasticity of demand. So that's what we have written. Of course, we have to throw in the minus sign because we define elasticity with a minus sign. So this is a second way to write that same equation. Yes. Now, the reason this is somewhat useful is that, among other things, it tells us that the monopolist, for example, will never, and I'm sure you've come across this this dictum in your undergraduate days that the monopolist will never operate on the inelastic part of the demand curve. Inelastic part of the demand curve means that's a point where elasticity takes value less than 1, right? Which means that this negative term is greater than 1, which means the entire left-hand side is less than 1, which cannot then be equal to marginal cost because that's positive, right? So whatever be the optimum choice of the monopolist, that will be a point where the elasticity of demand is greater than 1, right? It's elastic part of the demand curve. In a special case where there's no cost of production, it's just a resource which the monopolist just has, okay? There, you can see from this that, since the right-hand side is 0, the left-hand side has to be 0. That means elasticity has to be equal to 1, right? So when there are no costs involved, that means profit maximization is equivalent to revenue maximization, isn't it? And if you're interested in maximizing revenue, this equation tells you that you should sit on that point on the demand curve where elasticity of demand is exactly 0. When elasticity is less than 1, marginal revenue is negative. When elasticity is greater than 1, it's positive. That's something you can see from right here. But let me move beyond that. Here's yet another way to write this same condition, okay? Why is it equivalent? Well, this is just simple algebra, okay? I want to take out this term to one side, 1 over elasticity. So I'll have to switch the PM over here, right? And then I switch it to the right-hand side and bring in the other term here. And basically that gives me this equation. Again, just a little algebraic manipulation takes us from here to there. But this one gives us a little more insight. What's on the left-hand side? On the left-hand side, in the numerator, we have essentially marginal profit. If the firm sells 1 small extra unit, it'll fetch this price and it'll cost this marginal cost. So this is the marginal profit and it's being divided by P. So it's been expressed as a percentage of the price, right? What percentage of price is profits, right? So this is, you can think of this as the marginal profit rate of the seller at his optimum point, okay? So this is on the left-hand side. On the right-hand side, it's just the reciprocal of elasticity. So the marginal profit of the monopolist, or his profitability, somewhat broadly speaking, depends on the kind of demand curve he's facing, in particular, the elasticity of demand. If the elasticity is low, we have inelastic demand, then this is very high. And so the profit rate is going to be very high. On the other hand, if it's highly elastic demand, E is a big number, then this value is something small. So then the monopolist at the margin is not very profitable. Now, can we understand that beyond the maths? Sure. Monopoly is a lot of power. Yes, you're the sole exclusive supplier of a certain good. So maybe it'll make you rich, but it depends on what kind of good you're selling. Yes, if you're selling a life-saving drug, if you have a monopoly on the market for antibiotics or oil, that's a huge amount of economic power. You'll become absolutely stinking rich. And essentially, that's because the elasticity of demand is low. It's an essential, it doesn't have very close substitutes. So people can't stop buying it very easily. And so you can raise the price sky high, okay? On the other hand, if you're selling some fruit, guavas, okay, there are plenty of, for some reason you have the sole supplier of guava. Well, there are oranges, there are apples, there are bananas. So if you get too greedy and start charging a lot for your guavas, even though you have a monopoly in that particular fruit, you'll lose customers left and right. Okay, so there your monopoly power cannot be exploited too much. So this is something worth remembering as we discuss this, right? That monopoly is market power. It's a source of positive profits, but the nature of the demand curve, the nature of the product, in particular its elasticity property, is a check. Consumers can always vote with their feet. They can leave, they can buy something else. And that limits how much money the monopolist can make. Okay, Sakshi.
So my question is that in the second bullet point, we're saying that the monopolist never operates on the inelastic part of the demand curve.
Right.
But then we're also saying that the markup is equal to the inverse of elasticity. So if the elasticity is in fact low, that is, it's inelastic, the profits are large. So I don't understand how the two, I mean, what to conclude.
No, because even if you're on the inelastic part, which means elasticity is greater than 1, there's a whole range of values there, right? There's a whole range of values
right
above 1. And so if you think of, we're comparing two markets, two different products, each has a monopoly, and you want to ask, which monopolist is having a great time, a better time compared to the other. That relates to the elasticity of these two products, right? Both of them may be above 1, but for one, this may be 2, and for another, this may be 20, and those two monopolists have very different profit outcomes.
Got it. Thank you so much, sir.
Yeah. Okay, one more thing, and I'll end today's lecture on that. The big question is, so what, right? Is there a reason for us and our policymakers to be worried about a market which has become a monopoly? Right now there's talk of the telecom market. There were 1,000 players. It has shrunk to, some would say, 2.5. Jio, Airtel, and Vodafone is almost, well, I don't want to make sharp predictions, but many people think that there's a question mark on whether they will survive. Anyway, it's dangerously close to a monopoly. Okay. Why should we care as consumers, as economic policymakers? We should care because if a market becomes monopolistic, it becomes inefficient. Even that efficiency part does not apply anymore. So the quantity chosen by a monopolist who has no restriction, who is not regulated, quantity chosen will be less than the socially efficient amount. So let's see that. If this market was perfectly competitive, okay, then what would have been the quantity? Well, it would depend on the price equals marginal cost principle, yes. And if you apply that, whatever Q star satisfies this, that would have been the market outcome. So that's our benchmark. Since there are no externalities, none of those other factors involved over here, so therefore this Q star would be the Pareto efficient quantity, as we saw in the first topic of module. So this is the benchmark. This is what ideally should be produced. Okay. The claim is that a monopolist produces less than this. And so the price in a monopolistic market is more than in a competitive market. Quantity is less, price is more. How do we know that? First, let me show that mathematically, and then I'll give you the intuition. Suppose it's not true. Suppose the monopolistic quantity is not less, not strictly less, but weakly more than the competitive amount. So QM is greater than Q star. This is a proof reductio ad absurdum, right? I'll assume something, I'll show that that runs into some sort of contradiction. And so what I assume must be untrue. Okay, that's the line of reasoning. So to start with, assume QM, monopolistic quantity, is weakly higher. Since the demand curve is downward sloping, that immediately means that the monopolistic price is weakly lower than the competitive price. The thing is cheaper in the monopolistic market. Since the marginal cost is increasing, this is also true. Marginal cost for the monopolist is greater than marginal costs in a competitive situation. Now, you have two first order conditions. For the monopoly, you have this first order condition. This is one equation. And the perfect competition quantity is determined by this second equation. So I can subtract the left-hand sides and the right-hand sides and equate them, okay? So that's what I've done here. Subtracting the left-hand side of the two equations gives me this. Subtracting the right-hand sides gives me this. This is the marginal cost difference, and this is the whatever difference, yeah? Now, the difference that we get on the left-hand side can be written like this. It's the price difference between monopoly and perfect competition plus that extra term which was sitting there in the monopoly case. Now, on the right-hand side, this difference is positive because QM, we have assumed, is higher. So that means marginal cost here is greater, right? So this is a positive term. Whereas on the left-hand side, both terms have to be negative. Okay, give me 30 seconds. Okay, so that's the proof, right? We have run into a contradiction. The right-hand side is positive. Both terms on the left-hand side are negative. And so this equation cannot hold in that case. So that means our starting assumption was false, which means its opposite must be true. So that establishes that a monopolist will produce strictly less than a competitive market and charge strictly more. Okay. Now, what a competitive market produces is the socially efficient quantity. This is what we discussed in module 1, in the absence of externalities and such like. So monopoly leads to inefficiency and deadweight loss. Right? That's the classical sort of lesson that this is the reason why trying to prevent monopolies can be taken as an important goal of policymakers and economic regulators. And that's why, in most countries, you have laws which try to prevent monopolies from arising explicitly or implicitly. If there's 3 firms, but they are colluding, for example, they are deciding how much to produce to maximize their joint profits, that's effectively a monopoly. Okay. So the regulators try to prevent even that sort of implicit monopoly emerging through collusion in any market. Okay, so I'll stop there, but that's the starting point. What we'll do tomorrow is we'll look at some assumptions in this analysis, which is leading to the conclusion that monopolies are inefficient. And in particular, we'll sort of dig deeper into the question, are monopolists, so one assumption in this analysis is that the monopolist can only charge a single price per unit. Okay? It cannot charge different prices from different consumers, and it cannot do what is called non-linear pricing, that, you know, the first unit you buy will charge you 100 rupees, but if you buy a second, will give you a 50% discount. You only have to pay 50 rupees. The stores, various sellers often have that sort of non-linear pricing. Now, that has been assumed away in this analysis. So a big part of the discussion which is coming up is to do with price discrimination, charging different prices from different customers, and non-linear pricing in some form or the other. And the question will be that, you know, does the inefficiency of monopoly continue if the monopolist can do more and more sophisticated forms of pricing? All right, so I'll end there, and if there are questions, I'll take them.
Sir?